I think we got one more, but I think this time we're going to look at a graph. So the first two were functions. This one's now a graph. So we have three things for A, B, and C, from the left, from the right, and at -3. That's basically what that's saying. So here's -3 on the x-axis. Apparently it's off a little bit, but that's okay. So from the left of -3 means you're coming from this direction here. So you're asking yourself, what is the graph doing as x gets closer to -3? Well, notice this portion here, I can't really draw on it, is to the left of -3. So these are the x values to the left of -3. This is the corresponding portion of the graph that's to the left of -3. So what y value does the function approach as we get closer to -3? What y value? 4. Is everyone, hopefully you drew it that way. So as we approach -3 from the left, you're asking yourself, what y value does the function get close to? You would say 4. How about as we approach from the right? So now that would be this section of the graph. Now technically it would be all this stuff over here, but we only care about what happens close to -3. So as we approach -3 from the right, the function gets closer and closer to what y value? 4. Again. So I know we're throwing around these terms yet and we have yet to define them, but part A would say the left-hand limit is 4. Part B would say the right-hand limit is also 4. And part C, when you don't say left or right specifically, to find the limit itself, you have to make sure the left and the right go to the same place. Since the left goes to 4 and the right goes to 4, then we would say the limit goes to 4. So A, B, and C's answer are all the same, 4. So for the limit to exist, and we'll write this down later, the left-hand side must approach the same value as the right-hand side. Same number, I should say. Let's do this again for... So here's -4. As we approach the left, what value does the function get closer to? -infinity. So part D's answer was as we approach -4 from the left, the y values get closer to -infinity. So when you're answering these limits, you're answering the y value. How about when we approach from the right? What happens to our function? It goes towards positive infinity. So let's talk about the limit itself. The left one towards -infinity, the right one towards positive infinity. Are they going the same place? So, does the limit exist at -4? No. So you would say does not exist for part F. So for the limit to exist, it has to approach the same value from both ends. Is that okay? Actually, as it turns out, even when you go to infinity and not negative infinity, it still technically doesn't exist because infinity is not a solid number. It just goes on forever. So you're asking yourself, where are the y values going as x gets closer to 4? So who's got an answer for part G? -1. Here's the deal. So we don't care what happens at 4. So this is the big thing. Alright? It's going to be hard for everyone in chapter 11. We don't care about what happens at that functional value. We just care what happens as we get close to that functional value. Is that okay? So this one point is missing, but that will not affect the limit at all. We just know it's getting closer to it.
So even for part I?
Even for part I, correct. So as we approach from the left, the function gets closer to negative 1. So that's part G. As we approach from the right, the function again gets closer to negative 1. So from the left and from the right, we got closer to the same number, so part I's answer is negative 1. So again, we don't care what happens at that value, we just care what happens as we get close to that value.